Hey guys, Ms. Farron here. Welcome to Unit 2, Notes 3, Solving Systems by Elimination. So today we're going to solve systems using elimination. There are steps that go into solving equations used by elimination. Your first thing is you want to make sure that you're in standard form. This is extremely important. If you are not in ax plus by equals c, then you should not be attempting elimination. Either get it into ax plus by equals c, or go ahead and use a different form, which we'll learn later. So there's the steps below. The first thing you want to make sure is we are always going to add the two equations together so that one of our variables should cancel. If it doesn't, we need to make it cancel. From there, we're going to solve for the remaining variable and then substitute that back into the equation and solve for the other variable. So let's go ahead and look at example number 1 and follow our steps. So they are both in standard form already right now. The x and the y are on the same side. So we're going to go ahead and we're going to start with trying to add these equations straight down and see if something cancels out. Well, if I'm adding these, I end up having my x and my x's cancel out. I have an x plus a negative x, so those cancel. I have a 2y plus a negative y, so I give a 1y. And a 10 plus a negative 6 gives me a 4. So in this situation, I already know that y equals 4. I don't have to continue going forward and solving it all. So now I need to actually go back in and plug that y value into one of the original equations and solve for the x value. So I'm going to always use the first equation. I have x plus 2y equals 10, but I now know that y is going to be 4, so I'm going to get x plus 2 times 4 is going to equal 10. So x plus 8 equals 10, and solve for x now, so subtract 8. So I get x is 2. Your final step is to go ahead and you need to write this out as a point. So my x value was 2. My y value was 4. This is my solution that makes both of those equations true. So again, we want to go ahead and we want to add these straight down and see if anything eliminates right away. Well, my x's eliminate right away. A negative 2x plus a 2x, those are gone. A 3y plus a 2y gives me 5y. And a negative 11 plus a 6 gives me a negative 5. So I can divide by 5 on both sides to solve for y. And y is going to be negative 1. So now I'm going to go back in and I'm going to plug that in. Again, I'm going to use the top equation. It doesn't matter, but you want to use one of the original ones. So I'm going to plug the negative 1 in for the y value. So I get negative 2x plus 3 times negative 1 equals negative 11. So negative 2x minus 3 equals negative 11. We're going to solve for x. In which case I'm going to get x equals to a positive 4. So my solution again is going to be 4, negative 1. Make sure that your x goes in your x value and your y goes in your y value of the point. So now we're going to go ahead and look at number 5. We're going to try the same steps again. We're going to try to add straight down and see if anything cancels. Well, in this situation, nothing is going to cancel. I have an x plus a negative 7x. And I have a negative y plus a negative y. Because these are both negatives, they don't cancel. So we have to multiply one of the equations by something so that they do cancel. So we want to make this a positive, so we're going to multiply by a negative. So I get a negative x plus y is going to equal a negative 9. And now I can go ahead and I can add those two new equations together now. So now I'm going to add those two. So I get a negative 7 plus a negative 1. That gives me a negative 8x. My y's will cancel. A negative 7 plus a negative 9 gives me a negative 16. Divide by negative 8, divide by negative 8. So x is going to equal 2. So I'm going to go ahead and I'm going to go back to the original first equation, which was x minus y equals 9. And I'm going to plug in what I know now. I know that x is 2, so I get 2 minus y equals 9. And we're going to solve for y. So I end up with negative y equals 7. So when I divide by a negative 1 to get rid of that negative, I get y equals negative 7. So my final solution is 2, negative 7. So this actually ends up being our example number 4, and we run into the same issue we had before. When we add straight down, the x's do not cancel and the y's do not cancel. But because the x's already have the same number, we just need to make them one positive and one negative. So I'm going to change this one by multiplying by a negative 1. So I am now going to have a positive 4x, a negative 2y, and a negative 8. And now I can add those two equations straight down. So this one's kind of gone now. I am left with those cancel. A 1y equals a 2. So I know that y is going to equal 2. So I'm going to go ahead and I'm going to plug it back into that top equation that I kind of crossed off there. A negative 4x plus 2y equals 8. And I know that y is 2 now. So I'm going to do 2 times 2. So I get a negative 4x plus 4 equals 8. Subtract 4. So I'm going to left with a negative 4x equals 4. Divide by negative 4. So I get x equals negative 1. So my final answer, my x value was a negative 1. My y value was a 2. And whoop. So there's going to be my equation, or my solution. So for example number 5, our goal is going to be so that one of our numbers is the same number, but opposite, so that when you add them straight down, they cancel out. So I'm going to end up multiplying that bottom equation right there by a number. And I picked the bottom because that's like an imaginary 1. And it's really easy to multiply the 1 by something to change it into another number. So I need the 1 to look like a 4, except opposite. So I need it to be a negative 4. So I'm going to multiply this whole thing by negative 4. So I'm still left with my top equation. I'm just going to rewrite it to give myself some room. And now my bottom equation is going to become a negative 8x minus 4y equals a positive 32. Now I can add these things straight down. So I get a negative 11x, my y's cancel, and I equal 44. So divide by negative 11. I get x equals negative 4. So I'm going to go in and I'm going to plug that back into the original equation again. I know that x is now negative 4. And I need to solve this for y then. So I get 12 plus 4y equals 12. Subtract 12 from both sides, so I get 4y equals 0. Divide by 4, divide by 4. I know that y is going to equal 0 then. So my final equation is going to be negative 4, 0. And that's my solution. I want you to go ahead and try number 6 on your own. So pause the video, try it, come back, and check your work. So I ended up getting 4, negative 4. If you got something different, pause the video again, come talk to me, chat with a friend, see if you can figure out where you went wrong, but make sure that you understand it before moving forward to the next example. Okay, so for number 7, we still have a goal of adding these equations together to make one of the variables cancel out. So there is no way for me to multiply a 3 or a negative 3 by anything that's going to get me to a 10 or a 5. So we have to go about doing this a little bit different. We're still going to multiply, but we're going to have to multiply both equations by a different number. So I'm going to make the 3 and the 5, these two cancel out because of the fact that one's a positive and one's a negative already. So I'm going to make this one, I'm going to times the top equation by a 3, and I'm going to times the bottom equation by a 5. So let's see if that gets me to get something to cancel out. So I get 30m plus 15n is going to equal 15. And I'm going to get 15m minus 15n is going to equal 120. So if I add these straight down, my ends cancel out, which is exactly what I wanted. So I get 45m is going to equal 135. Divide by 45. So I get m equals 3. So now I can take that and I can plug it back into one of the original equations again. So I'm going to start with the top one. 10m plus 5n equals 5. So I get 10 times 3 now, plus 5n equals 5. Keep solving for n here. We need to subtract 30 from both sides. And then divide by 5. So I get n equals a negative 5. So when writing my point, we usually write the first letter in the alphabet first. So since m comes before n, we're going to write m before n. So 3, negative 5 is my solution. So 8 looks exactly like 7, where we have to multiply both equations by something to make a match. So I want you to go ahead and pause the video, try this on your own. Now is the time for you to make mistakes. So try it, see what happens, and then you can ask me any questions once you come back and check your work. So looking at this example, I got negative 5, 4 is my solution. If you multiplied by different numbers right in the beginning, that is just fine as long as you get the same solution as your answer. You could go about solving this in a couple different ways.